Day 50, Honors Physics, Conservation of Momentum, problem number 22. Here's a good problem, especially if you like canoeing like I do, although I would never jump out of a canoe like this. This is essentially an explosion problem, and the nice thing about these explosion problems is the total momentum is zero. You're assuming everything's at rest before they jump out, which is implied, so the total momentum is zero. So after the event, we have three objects. The total momentum added up for these three objects must be zero. So I therefore know, as you see in my diagram with the blue canoe, the blue canoe must be moving to the left because I can see that the smaller person will have less momentum than the larger person going the same speed in the opposite direction. So I'm going to calculate all these. I'll call this P sub 1. That's the 60 times the 2.5. So for this person, that's 120 plus 3. It's 150 units of momentum. To the left, as I have pictured, P2, pretty simple, same thing, 80 times 2.5, so that's 160 plus 40 is 200 kilograms meters per second to the right. So right now I have a net of 50 to the right, so the missing piece to bring me back to zero must be the canoe going left with a momentum of 50. I'm going to call that P sub 3 equals M3 V3, all of these representing the canoe. The total momentum there must be 50 to the left equals, well, this is real simple, 25 V3, V sub 3. So V sub 3 is 2 meters per second in the direction, it says calculate the magnitude, so that'd be in the direction of the smaller person. I'll let you write that down, I'm out of space, but you really should state the direction is in the direction of the smaller person, or you could just say to the left here. Since you have a diagram, or I have a diagram, I would give you full credit for that on the test.